Good morning, everyone. I am Mr. Ish. Thank you for joining me. We're doing here a logarithmic drill. We'll be looking at a bunch of questions over here. Excellent review of logarithmic simplification questions. Remember this before we start, because this will very much come in handy. Log base a, x is equal to y, and a to the y is equal to x. Converting a logarithmic into an exponential equation and or back. When you're looking here, log base 10, 100, you're looking here, everything equaling a y. Convert it into that exponential form, you have a a, you have a y, you're looking at 10 to the y is equal to 100. Therefore, y must be equal to 2 and your answer is done. Let's try this one, log base 4, 64x. How would you solve for this? Well, again, everything is always equaling a y. Use that conversion there. We have this. Use a base to the power of y is equal to 64x. Convert this into bases of 4. You have 4 to the y is equal to 4 to the 3x, because 4 cubed is 64. Then you have y is equal to 3x, and there is your answer, 3x. Because we've eliminated the bases, y is equal to 3x, and 3x is a good answer. And that question is done. How about this one right here? We're looking here at log base a. We have 1 over 1000 is equal to minus 3. We have to find a. How can you do it? Again, convert this into that form. You have a to the power of minus 3 is equal to 1 over 1000. If you want, you can view this right here as 10 to the minus 3. You have a to the minus 3 is equal to 10 to the minus 3. Therefore, a must be equal to 10. So you're looking here at everything with regards to the base a. And this right here would be your answer, 10. 10 is good because log base 10. 10 to the minus 3 exponent is 1 over 1000. How about this? We're looking at this natural log now, e to the 2x. How can you view this? Well, remember this. Log to the base e is equal to natural log. So wherever you have a natural log, you're looking at a log, but it happened to have a base e. But this right here is not your base e. This right here is basically your x value right over here, because it's like that. You can convert this into this. Now we're looking at log base e. E to the 2x is equal to y. Now convert everything into that exponential format. E to the y is equal to e to the 2x. Therefore, y is equal to 2x, and that right there is your answer. Natural log e to the 2x is equal to 2x. And that right there is done. Let's look at another one. Natural log e to the minus x cube. How can we do this? Again, convert everything here into a log form. You're looking here at a log base e, then you have e to the minus x cube. All of this is of course equal to y. You have e to the y is equal to e to the minus x cube. Therefore, y is equal to minus x cube, and this here is your answer. Let's look at this question. You evaluate, you simplify whatever you can with this. What can we do with this? Well, you can use the properties of logs. You have basically a natural log 1 minus natural log of e squared, because this quotient over here, this divide, is equal to a difference with the items in their separate logs. Natural log 1 is basically the same thing as log base e of 1. A log of 1 is always equal to 0. Natural log of 1 is always equal to 0. Here you have minus natural log e square. This here is a 0 minus. You can look at this as now e and then square. If you want, you can bring this right here utilizing the properties of logs. You're looking at a minus 2 ln e. But ln e we know is always equal to 1, so you're really looking at a minus 2. And that right there would be your answer, minus 2. Let's evaluate this. We have to simplify this compound expression, bring it into a most simplified form using the properties of logs. What are we doing over here? How about we look at it this way? Our step over here is natural log x plus natural log x plus 5. And you have this 4 sitting here, because this coefficient 4 can come here as an exponent. This coefficient here can come as an exponent, and then we have natural log x plus 3 to the power of 2. What we can do is start consolidating things. When you have a positive and natural logs, you can bring them as a single unifying term, but as a product. When things are adding, you bring them as a product. You have a natural log x times x plus 5. You have everything here to the power of 4. When you have a difference here, you're really looking at a quotient. You're looking here at natural log x plus 3 whole square. But everything can be brought under a single unifying natural log. We'll have a natural log. And we can have over here x times x plus 5. You have all of this to the power of 4 divided by x plus 3 whole square. If you want, you can combine this. You'll have x squared plus 5x. Or you can leave it as this. But this answer right here looks good to me. In this question, we have to expand everything. From a unifying expression, we have to open it up. What can we do here? Well, we know we have a product over here. These two are in a product. This here is in a divide. So this product here will bring a positive. This divide will bring a negative. You have a natural log x to the 4 plus natural log root y minus natural log z cubed. What we can do now is get rid of these exponents. This root y is really a 1 over 2 exponent. We have a 4 natural log x plus 1 over 2 natural log y minus 3 natural log z, and that right there would be your final answer. Our question is this: we have a log with a base b, we have a cube root xy divided by z plus 1 whole square. The first thing you want to do is get rid of everything here with regards to this exponent. You have a log base b, and then you have an xy over z plus 1 whole square, all to the power of 1 over 3, because that's exactly what it is. But this 1 over 3 can come right out here, and when we put it out here, everything will now be impacted with this 1 over 3, because 1 over 3 is impacting this already as a cube root. You really have now a log base b. These two x and y are in a positive relationship because they're products. When you separate them into their individual logs, they're in a plus relationship, and you'll see that log base b y. This quotient transforms into a minus, and then you have a log base b z plus 1 whole square. But we can even present this in a better way. This 2 can travel and come right over here, and that's exactly how I want to show it, right over there, and you've seen it. Now what we can do is open up the parentheses and impact everything with this 1 over 3. We'll have a 1 over 3 log base b x plus 1 over 3 log base b y minus 2 over 3 log base b z plus 1, and that right there would be my final answer. And there it is. Let's look at two more questions. In this one we have to simplify or rewrite this expression. I would very much like to remind you of this specific property: e to the ln x is always equal to x. I've shown you how that can be verified in one of my previous videos, verification of logarithmic identities. Remember that e to the ln x is always equal to x. Likewise, e to the minus ln x will equal to 1 over x, and I've proven these two for you in that video. I can include the tag for that video in this one, but you can pay special attention to those two specific properties. When you're looking at this, you know based on that property this answer should equal to 5x plus 3, but we have to show it to be the case. We're looking here at everything always equal to y. Take this here and invoke the natural logs. You have a natural log of 5x plus 3 is equal to natural log of y. You've eliminated this. This you could write here as a natural log e, but we don't need to write that down because natural log e is always equal to 1. You have this. So what do you do over here? You bring in this natural log 5x plus 3 minus natural log y is equal to 0, and bring everything here under a unifying log. You have a difference here, it brings a quotient. 5x plus 3 over y is equal to 0. Get rid of that natural log, take it to the other side. You have a 5x plus 3 over y is equal to e to the 0, which is equal to 1. And then 5x plus 3 is equal to, as you figured out, you can take y on the other side, and there it is, your answer. If you were to rewrite this or simplify it, your answer is just simply 5x plus 3. Whatever you see right here in your exponent is your answer, except don't bring in the natural log, but I've shown you this procedure here. Let's look at this one. E to the power of minus natural log x over 5. It looks very much like what I was showing you. E to the minus natural log of x would be 1 over x. So you should have an answer which should be something like that, 1 over x. And you know x here is x over 5. You would have something 1 over x over 5, which would translate into a 5 over x. That should be your answer. If done properly, that's exactly what we'll obtain. And how do we go about doing this? Make everything equal to a y, and then use your properties of logs and continue from there. You have a minus natural log x over 5 ln e is equal to ln y. I've brought the exponent here as a coefficient by bringing in the logs, the natural logs. This goes away. I have a minus natural log x over 5 minus natural log y is equal to 0. You can do everything here in terms of a minus and eliminate the minus by isolating it, and you'll see what I'm doing right over here. You don't have to do it this way, but you could. Take the minus on the other side, it impacts with the 0 and it stays the same. You have natural log x over 5 plus natural log y is equal to 0. When you took the minus on the other side, 0 divided by minus means nothing, it's still a 0. Now you have here a product coming through here with regards to your logs. The sum of two items and their individual logs is their product when combined under a single log. You'll have here natural log x over 5 times y is equal to 0. You have an xy over 5 is equal to natural log going on to the other side, which is e to the 0, which is 1. Xy is equal to 5, and then y is equal to 5 over x, and there it is. You have seen it come about. So remember this specific property, highly important, and this one right here, e to the ln x is equal to just x, highly important. These properties are just very important and they should not be forgotten. And with that, let's end this video. Thank you for watching. Have a great day.